Welcome to Desai Academy of class 9th, chapter number 3, atoms and molecules. In our previous videos, we discussed that what is the meaning of padartha and the meaning of paramanu by given by the Indian philosophers what Pakadu Kattamaya and also Maharshi Kannada, and also these same theories given by the two Greek philosophers what Democritus and Leucippus are to the two scientists given the matter can be divisible into what tiny particles, and these tiny particles called as atoms. And also we also discussed that the chemical combination or laws of chemical combinations given by the what scientist as what a scientist Antino L. Lavoisier is the what a founder of law of chemical combination. You want videos of this chapter means please search in our playlist. You will get all the videos of this chapter, and also we will get the videos of class 8th and class 10th also. So next we'll start our topic name called as chemical laws or laws of chemical combinations, right? The following two laws of chemical combinations were established. Okay, there are two chemical laws explained by the scientist by doing some experiment called experiment by which two scientists? So one is Joseph L. Proust and another is Lavoisier. These are the two scientists, Lavoisier and Joseph L. Proust, are given the laws of chemical combinations. Remember that. Who given the laws of combinations? Two scientists. One is Joseph L. Proust, another is Lavoisier. In the first law of combination comes law of conservation of mass. Okay, what is the law of what is the first law? That is the law of conservation of mass. What is law of conservation mass? How it will works and the statement of conservation mass we will discuss in detailed manner. Okay, there is a change in mass when chemical change takes place. Okay, question arises here: when chemical reaction will takes place, then chemical mass also there is a what chemical changes occurs means there is a changes in mass or not, have to observe here. Okay, whenever chemical reaction will taken place means there is also change in its mass. Okay, for that we are having activity 3.1. so we have made two columns. One is x column, another is what y column. So in a x we are having different types of solution, in y also having different type of solutions. Okay, x having what copper sulfate. The chemical formula of copper sulfate is what CuSO4. What is the formula of copper sulfate? CuSO4. You can note that the chemical formulas of these compounds. Again, barium chloride, BaCl2, that is the barium chloride. What is the formula of barium chloride? BaCl2. And the copper sulfate formula is what? CuSO4. And lead nitrate. What is lead nitrate? PbNO3 2. So this is the lead nitrate. What is the lead nitrate formula? PbNO3O2. Okay, how to write bracket? Okay, what are the three compounds where they are given? Copper sulfate, first compound, right? Second one, the barium chloride, BaCl2. Third one, the Pb, right? Pb. Okay, once again, so we'll write here. Okay, so we can write very small font, so right. Okay, so what? PbNO3 bracket 2. Okay, this is called as what? Lead nitrate, PbNO3 2. 2. So this is the 3 compounds present in X column. Okay, you can note these compounds formula. Okay, next sodium carbonate Na2CO3. What is the formula? Sodium carbonate Na2CO3 and sodium sulfate NaSO4. This is the sodium sulfate. Again sodium chloride. Okay, NaCl. This is called as what? Sodium chloride. This is the sodium carbonate Na2CO3, sodium sulfate NaSO4 and sodium chloride NaCl. These are the some chemical formulas of what? X group and Y group. Right? These are the what? Some important chemical formulas given in the activity. Prepare separately 5% of solutions of any one pair of the substance listed under X and Y, each in 10 ml water. Okay, how to take from this X solutions, X compound and Y compound, and how to mix in how much? 10 ml water. Right, from the X compound you have to take it, and from the Y compound you have to take and mix with water, 10 ml water. Take a little amount of solution of Y in a conical flask, some solution of X in a ignition tube. Okay, so you have to take a small amount of solutions from the Y. Okay, like this. This is what this is what a conical flask. Already we have taken some water. Y solution. In this we have taken a conical flask Y solution. This is what small ignition tube. In that we have taken X solutions, right? So this is the bigger picture that in having what? A conical flask, and this smaller one is called as what? Ignition tube. In the ignition tube we have taken X compound of 3 compounds. In that any one we have taken here, and the bigger is called as a conical flask that contain Y solutions. This is the what? Activity is given here. Hang the ignition tube in the flask carefully. Okay, how to tie up and how to hang the what? Ignition tube in the conical flask, as you can see in the picture. See that the solutions do not get mixed. Put a cork on the flask. Okay, so they should not be what? Mixed with each other. You have to place a cork on the what? Mixtures, right? This is about the what? Simple activity. Okay, weigh the flask with its contents carefully. How to measure the conical flask and ignition tube. Now tilt the swirl and the flask so that the solution X and Y get mixed. Okay, so before mixing you have to measure the weight of the both test tubes. After, if you are mixing this test tube with each other, X and Y we are mixed, then measure the total mass of the X solution and Y solution. Right, understood? Before mixing how to measure, and after mixing how to measure. This is a simple activity they are given. What happens in the reaction flask? Do you think that the chemical reaction has been taken place? Yes, there is a chemical reaction will happen. Why should we put a cork on the mouth of the flask? So does the mass of the flask and its content changes? Okay, question arises here. If chemical reaction happens means so the masses will changes. So we are saying that the mass cannot be changes. So that is the first law. Will say that what is that? Law of conservation of mass. What they will say is the what is the statement of law of conservation mass means the law of conservation of mass states that mass can neither be created nor be destroyed in a chemical reaction. Very important definition. What is the law of conservation mass? Mass can neither be created nor be destroyed in a chemical reaction. Whenever chemical reaction will occurs, the mass cannot be changes or can neither be created nor be destroyed. So we cannot create a new mass or we cannot destroy the we cannot destroy the mass. So whatever the mass is there, it remains same. We cannot create, we cannot destroy also in a chemical reaction. So this is about what law of conservation of mass. Okay, remember that. What is the law of conservation mass? Mass can neither be created nor destroyed in a chemical reaction. Whatever the compounds we have take, whatever the solution we have taken, so in that solution chemical reaction will occurs in that. So there is no change in its mass. Earlier what is the mass is there, after the reaction also mass remains same. So it cannot be created and we cannot destroy mass already it presents. Okay, this is about what law of conservation mass is. Mass can neither be created nor be destroyed in a chemical reactions. Thank you for watching. Please subscribe my channel and share with your friends. Thank you.